Now, a powerful eruption caught on camera at Yellowstone National Park has sent debris raining down on visitors.
Yellowstone, the sleeping giant's uneasy slumber. The park's famous steamboat geyser, the tallest active geyser in the world, has erupted 14 times this year, 4 in October alone. Each one an explosive display of boiling water and steam that towers over the surrounding pines. Tourists flock to the Norris Geyser Basin to witness the spectacle, their phones raised as steamboat roars to life. To the casual visitor, it's awe-inspiring. But to park rangers and scientists, it's also a warning. The park's hydrothermal system is reawakening. When you've worked here long enough, you can feel the changes. The ground hums differently. The geysers go off more often. The steam smells sharper, like burnt metal and sulfur. It's beautiful, but it's powerful. You never forget what's underneath this place. The expanding magma chamber beneath Yellowstone. Recent studies have revealed that the Yellowstone magma chamber is slowly expanding. Using data from both satellite radar and GPS instruments anchored across the caldera, scientists have detected a steady uplift of 6 to 7 centimeters, a sign that magma and volcanic gases are intruding into the upper crust. A new USG of University of Utah report, released in late October, states that the molten fraction of Yellowstone's reservoir has increased from 8% to approximately 11% over the past year, an amount significant enough to raise pressure within the chamber. This is part of Yellowstone's normal recharge process. It happens every few decades. What's different this time is the intensity of the gas emissions and the consistency of the uplift. The system is alive and it's becoming more active. The park has experienced more than 1,100 earthquakes since August. Many shallow and clustered near Norris Geyser Basin, the same area where Steamboat resides. Instruments have recorded spasmodic tremors, long, low-frequency vibrations associated with moving fluids and gases. Mount St. Helens, the volcano that rebuilt itself. Mount St. Helens in Washington State. For decades, the volcano has been under close observation since its catastrophic eruption in 1980, which blasted away its north flank and reduced its summit by over 400 meters. That eruption remains the most destructive in modern U.S. history, killing 57 people and reshaping the landscape of the Pacific Northwest. Now, the volcano shows fresh signs of movement. Since mid-2025, scientists from the Cascade Volcano Observatory have documented hundreds of small earthquakes, most less than magnitude 2, beneath the southern and central portions of the crater. Thermal imaging has detected hot spots up to 40 degrees Celsius warmer than surrounding rock, and sulfur dioxide emissions have nearly doubled since spring. Mount St. Helens never really went back to sleep. It's been refilling slowly for years. What we're seeing now, minor uplift, deep quakes, increasing gas, it's the same pattern that preceded the 2004 dome building eruption. It's rebuilding, one breath at a time. CVO scientists continue to fly drone surveys into the crater, mapping new vents and monitoring for dome deformation. The data feed directly into GVAN's global system, where Yellowstone's patterns, St. Helens activity, and Iceland's eruptions are all cross-referenced for shared trends. Iceland's Reykjanes Peninsula, fire in the North Atlantic along the Reykjanes Peninsula. Where the North American and Eurasian tectonic plates diverge, the crust is splitting open. For the 5th time in 4 years, lava has burst through the surface. in late October 2025. An earthquake swarm exceeding 2,000 tremors rattled the region in just 72 hours. Roads cracked, steam vented from fissures, and residents of Grindavik were ordered to evacuate as magma crept closer to the surface. At 3:14 a.m. on October 29th, a new fissure opened along the Sudninkur crater chain, producing lava fountains up to 50 meters high. The eruption continued for days, illuminating the night sky with an eerie orange glow that could be seen from Reykjavik, 40 kilometers away. It was like the ground just opened and started breathing fire. You could see the lava flowing over the black rock from last year's eruption. It was beautiful and terrifying at the same time. IMEO volcanologists have deployed drones and thermal sensors to track lava flow rates and gas composition. They've recorded high levels of sulfur dioxide and rapid ground deformation, consistent with an ongoing rifting episode. A geological process in which the crust stretches and repeatedly fractures, forming new volcanic vents. This is part of a long cycle. The Reykjanes Peninsula is entering another rifting era, which could last for decades or even centuries. We're witnessing the creation of new crust, the planet building itself. Global coordination, listening to the Earth's network, monitoring these simultaneous volcanic episodes, has become a test of modern global coordination. Global Volcanic Activity Network, GVAN, an international partnership among USGS, IMO, Japan's JMA, and the European Space Agency, now tracks over 1,400 active volcanoes using a blend of seismic, satellite, and atmospheric sensors. We're not saying these systems are linked directly, but they're responding to similar deep earth forces, shifts in mantle convection, crustal stress, or magma pressure redistribution. When we see activity rise in multiple regions, it tells us something fundamental is changing within the planet. In early October, AGVA, an alert system, flagged simultaneous deformation in several high heat zones, Yellowstone, Reykjanes, and Italy's Campi Flegrei, prompting an increase in satellite overpasses and gas monitoring. For scientists, it's a chance to better understand how Earth's internal pulse operates, how cycles of heat, pressure, and release shape continents and oceans over time.